Hello everyone, in this video I will demonstrate a simple software-defined networking environment using Mininet, OpenFlow POX controller and Wireshark. And the main purpose is to show how SDN separates the control plane from the data plane and how forwarding behavior can be managed using OpenFlow. And in this demo, it's going to be run inside a Ubuntu virtual machine. The main reason because like Mininet, POX, and OpenVSwitch work best in Linux. Yeah, they are designed to work on Linux environment. Also, the virtual machine also lets us stimulate the host switches, the links to connection, and the controller on one laptop without any physical network hardware. And now, first I'll start the POX controller. I would say that all the tools I already installed in my virtual machine and show the instruction before this video. So please read through it before watching this video and starting the demonstration. Here, let's open a terminal and then go into the file. POX. Yep, I already started the POX controller, and this controller represents the control plane and listens for the OpenFlow connection from switches. Next, let's open another terminal to start the Mininet topology. Yes. Oh, sorry. And here I already create a Mininet topology with two hosts, H1, H2, one switches, S1, and yeah, the connection between them also connect to the POX controller as well. And here, host 1 and host 2 communicate to each other through the switch 1, and while the POX controller will manage the forwarding decisions. And here, after I create this topology and connect to the POX controller, the POX terminal right here show that the switch has connected to the controller right here. And this confirms that the OpenFlow control channel between the switch and controller is working. And next, I will open the Wireshark before running any command to catch the message, the communication between the host 1 and host 2. So let's open another terminal to open the Wireshark. We choose look back here, and then we choose look back interface because the controller and the switch are running inside the same virtual machine, and we need to use a filter, apply a filter, which is TCP port 6633. This is because like the POX commonly like as default use the TCP port 6633 for OpenFlow communication. And sometimes we also can use OpenFlow like v4, but sometimes like the filter may not show the packets in this setup because the POX is using a older OpenFlow like version. Here, sometimes we also can use OpenFlow v4, but they show nothing. So here I will use the TCP port 6633. Yeah. And now I will come back to the topology and use command ping the text to test the communication between host 1 and host 2, which is h1 ping c4, which is like just receive 4 reply here. Yeah, the successfully replies show that the packets can travel through the OpenFlow switch. And let's go to the Wireshark to see the packet. In the Wireshark here, as we can see, the traffic like TCP traffic on the port 6633 showing represent the OpenFlow control communication right here. For example, packet in, packet out. We will talk about this from like more particular like on the next video. So yeah, this is showing the communication between the controller and the switch. And then next I will like so now I will clear the previous flow in tries using the delete flows so that the switch only use the rules that I'm about to add. Here I will, yeah. This is like this part is like manually add a flow rules to the controllers. First I will delete the rules before. Yes. Awesome. And then I will add the first route that route matches the IP packet where the destination address is 10.0.0.1, which is host 1, and the action is output 1, tells the switch to forward those packets out of part 1, which connects to the host 1. Sudo add a flow S1 and priority output is 1. Then I also add the second route, which matches the IP packets where the destination address is 10.0.0.2, which is host 2 as well. And this will, the action should be output 2, which tells the switch to forward those packets out of the port 2, which is connected to the host 2. Connect to the host 2, and the destination is the host 2. Yeah. And this demonstrates the OpenFlow mesh and action model. Instead of the switch making forwarding decision by itself, forwarding behavior is defined through the flow rules. And the switch checks the packet fields, such as the destination address that I put right here, and then applies the action specified in the route. And here for the priority to equal to 100 means that these routes are evaluated before lower priority routes. This is important because OpenFlow switches may contain multiple routes, like a lot of routes, and the highest priority matching route is applied first. And now let's see the table before we starting to run the communication. Sudo sorry. Here, when we first see the table, there's no packets, then there's no byte in the table, but as we can still see the destination and the action. And now let's run the ping command. Sorry. Then come back to the terminal. Oh, this is this. And then let's see the table again. Here, after we run it, we can see the amount of packets and the bytes increase. The byte counters increase, which show that the packets are matching the installed OpenFlow rules. And this confirms that the traffic between two hosts is being forwarded according to the programmed rules in the switch. Yeah, and this demonstration showed a working SDN environment using Mininet, POX, Open vSwitch, and a Wireshark. It demonstrated the controller and switch between the communication between switch and controller, OpenFlow traffic, flow table in tries, and also the mesh and action forward model right here. And yeah, compared to the traditional networking, this shows how SDN allows forwarding behavior to be centrally controlled and program more flexibility. Yeah, thank you for listening, and let's move to the next part.